Today let's take a look at this Tripp-Lite SM6735 UPS. Now this particular one is a line interactive UPS, which means it has an auto transformer with a bunch of relays and a whole bunch of taps which will adjust for the incoming line voltage. Now in North America it's 120 volts. If it goes down or up, I believe this goes down to 90 volts and it will still be able to compensate. So this basically will adjust the different taps on the relays and the transformer to keep it at 120 volts output, even if the input varies. So on the front, you've got very few controls. I mean, it's really just some incoming AC, some load indicators, battery indicators, whether or not the it's under or over voltage. And there's just a power button and a silence button. This is obviously a 1U rack design. On the back we have the 7 outputs, although one of them is just surge protected and one of them says it's switched, so I'm guessing they have a relay inside to keep the to use this as like an on-off switch. There's also a circuit breaker. These are interfaces to the onboard control system that will notify a computer whether or not the power's gone out. Basically, if you're hooked up to the RS-232 or the USB, you can have your computer shut itself down if it sees that the power's gone out and the batteries are about to die. There's a ground hookup. I don't know what the EPO is. That's probably their own proprietary like serial connector. And there's also an option card installed that has an Ethernet port, configuration port, which is probably serial, and an EnviroSense port, which I believe connects to different monitoring things like fire, that kind of stuff. So you can, and possibly temperature as well, that can trigger shutdowns or whatnot if certain conditions are met, like an emergency. So I've taken most of the screws out of this thing, but I'll get the rest of them out. So the input cable is this really heavy duty, very heavy duty power cable, and it's just a standard North American plug. Now when you're looking for UPSs and devices like this, like big power strips, that sort of thing, on eBay, especially stuff for server environment or enterprise environment, they can often have high amperage connectors that will not fit in a standard outlet. So gotta watch out for that. This particular one does in fact work in a normal outlet. So we can see the basic layout of it. There's 2 flat batteries that go here. This particular one came with 2 dead batteries, although I do have the hookups for the batteries. These just connect to although I do have the hookups for it. These connect to the batteries and this joins the 2 to just make a single 12 volt pack. The batteries are actually 6 volt instead of normal 12 volt batteries. There's a very flat transformer here with all the taps running off to the relays and stuff in the corner. There's also the H-bridge configuration MOSFETs here to run the PWM sinusoidal output. Now this does actually do a proper sinusoidal output instead of just a square wave. So that's also a nice feature, and it's only found on more expensive UPSs. But basically the layout's pretty simple. You just have a microcontroller and, like I said, the H-bridge stuff. And then there's a big pile of relays over here for the auto transformer, and then a main bus bar connecting all the outlets. So this is the expansion connector. Now apparently they have different types of card that you can put in here. Some that just do emails, that sort of thing. But the little front plate is not attached to the card. So you can't just like pop this out. You have to take that plate off and then like grab the card and get it out, which seems really silly to me. Since everything's so cramped in here, I think what I'm going to do is just unscrew everything and take it all out right now at once. And we'll take a look at the individual parts. Now, with something like this where there's a lot of taps on the transformer, with all these multiple connections to the board. I'm going to take a bunch of pictures before I disconnect everything, just so I know where everything's running and I can hook everything up without starting a fire. Along the back of all the connectors for your battery backed up devices, you can see that there's a PCB linking them all, and it's all just exposed mains wiring. So do not go anywhere near this thing when the power is connected or when the batteries are installed, because the batteries could be providing the 120 volts as well. So you have to make sure that you're only touching this thing when everything's removed. One thing to note is that there's a whole bunch of connections into this thing from the motherboard. Now, it looks like at least one of them is used to switch on that switch, the one port on the back that says it's switched. But the rest of it, I'm not really sure. It says this thing is a line interactive supply, but the transformer, let me grab this thing. The transformer only has 3 wires coming out of it, which is weird because a regular auto transformer like this would usually have a lot more taps. So I don't know what they're doing with this thing. The manual does say it's line interactive and that it does adjust the voltage. So they might be doing something kind of unusual with the relays, which we can take a look at in a second, but it does seem a little weird. This is the interface board, and you can see it's just the push buttons, the LEDs, all nicely silk screened, and the buzzer. There's also a large relatively large electrolytic capacitor for this HC59574HC595 expander chip that they're using to drive all the LEDs and stuff. And yeah, there's a few resistors, and that's about it. Just connects with a long ribbon cable to the main board. As we saw earlier, this is the Ethernet board, and it just slides into this unit, which is part of the, or it's screwed onto the chassis, and it just uses the edge connector, and there's only a few connections to the board. And if we take these self-tapping screws out, so with that part removed, you can see that this piece is actually a flat piece of plastic that's, injection molded or whatever, but they make this part thin to turn it into a hinge, and then that is held together with this, well, down here. But yeah, it's kind of a interesting piece of design. It's neat how you can use plastic in ways like that where it's got a hinge built in. You can do this with 3D printers as well, although in general, the plastics used in 3D printers don't hold up to this too well unless you're printing like nylon and stuff like that. Down on this end of the main board, you can see that there's 4 relays which are being used to do the auto transformer portion of how this thing works in some weird configuration. So these are switching in and out different taps and configurations to adjust the output voltage based on the input voltage. And there's a bunch of fusible resistors, looks like some caps, and big huge MOVs with heat shrink around them. There's a small, oh, that's a current sense transformer. You can see it's labeled CT1. There's only 1 winding there. And, or actually no, it looks like there's a couple there, but usually they just have like 1 loop or 2. And some more protection stuff, whole bunch of transistors. These are probably driving each relay. And we have a bunch of these, which look like MOSFETs as well. And they are on these interesting little heat sinks. They're just metal slugs, which I think is kind of funny. I'm going to resolder this since I'm not sure if I loosened the traces or the cracked the solder, but it is kind of interesting how they're just like lugs of metal. We've got a microcontroller here. I presume if I have, maybe this will get it off. The right tool to get this thing off. Can't read that. Hang on, I'll get in for a closer look in a second. Oh, there's another programmable chip here. It's probably a PAL or something for the all the I/O, or maybe it's a you know what this might be? This might be a Cypress USB controller. Yeah, that is Cypress, so I think that's just a the USB controller, and it probably has programmable firmware. And what else we got? We got some a big diode and the big 30 amp fuses. These are coming in from the battery connection, and they're car style blade fuses, which you can't actually remove, which is kind of silly. Big output capacitors right next to the H bridge. If you look carefully, these are actually wrapped in heat shrink, which I don't think I've ever seen on a electrolytic capacitor. At least not on like a, maybe on like a gigantic one, but not on ones this big. Over here we've got, this is all for the a secondary power supply, I believe, because there's a 12-volt regulator here, and this is a tap from the transformer. So I think what they're doing is they're just powering either part or all of the circuit with this, and they seem to do another one over here, although this could be some kind of sensing tap. And oh, no, know what they're doing? There's another, this is another regulator. So they actually have two separate power supplies here. There's a small fuse here, no fuse on this, no fuse on this one though, and there's also a little selector down here. I wonder what that's doing. Or is that a pot? Oh, yeah, that is a pot. I thought it was an actual like a selection dial, but it's a, we have a 5-volt regulator with no heat sink pressed up against electrolytic capacitors. That's smart. Clock crystal for the USB probably, or well, for this probably to provide the USB clock. No surprises here, it's just an ST 8-bit microcontroller, and right over here is 2 kilobytes of flash. Well, it's actually EEPROM from Microchip, so that's obviously the firmware for this thing. Looking at the Ethernet board, there's a Digi ARM processor. It's the NS9210, which is a 150 megahertz with 4 megs of flash, 8 megs of SD RAM, Ethernet controller, all that kind of stuff. So the board is using this as some memory, which looks like it's like, 32 megs or something. Little clock crystal, backup battery, various little part. That's probably the PHY for the Ethernet controller. And on the back, there's some spansion flash, nothing. And DC to DC converter. Wow, that's a really tiny chip. That's got to be an, I don't know if that's an 0603. I think that's an 0603. That is a tiny, tiny package right there. And you can't have a teardown without a bad capacitor. I wonder if this thing even worked. I know the lights came on and stuff, but I wasn't able to actually reach it via Ethernet, but that could just be a software thing. But this cap is definitely bulged out, especially when you compare it to this one. I'm still not positive how they're doing the auto transformer aspect of it with just relays and only 3 outputs from the transformer instead of, like 6 or 10 like they normally have. So I'm not positive how they're doing that on this thing.